Okay, we want to begin now in section 5.8. And so what you're going to need to do, now we're going to use all of the stuff that we just covered in factoring. But I want you to take that and the factoring concept, slide it to the side because we're going to use all of that. But we're going to be talking about something very different in this section, yet it's going to look very, very similar in this section. And so let me just kind of introduce this topic first, and then we'll talk about how we work these problems. If you look at this right here, and this right here, we talked about earlier in chapter 5, we talked about what polynomials were. And I gave you the definition of a polynomial, and we talked about binomials, and we talked about trinomials, etc. So this is a polynomial. More specifically, it's a binomial. This is a polynomial. Now, I could put other letters in it, and it'd still be a polynomial, as long as the exponents were positive. But both of these are polynomials. Now, if you look at the difference in this and in this, the difference here is this is an equation. So is this a polynomial? Yes. Is this a polynomial over here? But it has an equal sign in it. So if you were going to give this a name, you can't call it just a polynomial. Because it has an equal sign in it, you have to call it a polynomial what? Equation. If it has an equal sign. You remember your test 1 had the first 6 or 7 problems on your test were equations. All of those problems on your test, on your midterm, was called polynomial equations. But we gave it a special name and we called them linear equations. Now you probably don't remember this, but I'm going to remind you. I told you that a linear equation is an equation where it's got a polynomial in it, but it's the same letter every time, and it's always to the first power. So you may have a 3x plus 7 plus 8 times x plus 1 equal 5 times x minus 7 plus 3x. So you may have that x listed multiple times, but it was always a single variable, and it was always to the first power. So this is a linear equation, but you could call it a polynomial equation also. But a better fit is called linear equation. Let me use this analogy with you. If I say the word ball, that's a broad topic. But if I use the word baseball, that's a lot more specific. Now, is a baseball a ball? Yes. But if I held up a baseball and I said, what is this? If you said ball, you would be correct. If you said baseball, you'd be more precise. So if you call this a polynomial equation, you're correct. But if you call it a linear equation, you're being more precise. Because what you're saying when it's a linear equation is not only does it have letters in it, it has only one letter in it, and it's always to the first power. So just to show you one more, like what you had on your first test. This one is a linear equation. Now, what do we do to equations? We solve it. In other words, we find the answer for x that makes it true. Now, we don't solve problems if they're not equations. Think about the last 30, 40, 50 examples that I did with you in chapter 5. Did I ever ask you to solve any of those problems? No. I asked you to factor it, but I didn't ask you to solve it. Factoring means to find out what multiplies together to give you that. So in none of the problems in 5.5, 5.6, or 5.7 did we solve for x. They were all polynomials, and we factored the polynomials completely, but we didn't solve anything. No equal signs. Now, what I want to do is I want to pick up with polynomial equations, but what is the difference in this polynomial equation and this polynomial equation? Well, let me go back and talk about one more word that was that you covered in chapter 5, and it was the word degree. Remember, the degree of a polynomial was the biggest power on x. if your polynomial equation is degree 1, biggest power on x is degree 1, we call that linear equations. We've already discussed how to solve linear equations. We did some with fractions, we did some with decimals, so a whole lot of problems. All that stuff we did in 2.1, all those videos, all of those were linear equations. Polynomial equations, degree 1. Well, what we want to do now is we want to talk about how to solve polynomial equations with degree 2 or higher. So in other words, how do we solve this right here? Now, before I talk about that, the way you solve this equation is not the way you solve a linear equation. You may or may not remember me saying this. I told you the word equation in mathematics is like in athletics the word ball. If I say football and then I say basketball, are they both sports? Yes. Is the goal, if it's competitive sports, what's the goal? It's to win if you're competing against each other. So the goal to football, the goal to basketball, if it's competitive, is to win. The goal to a second degree equation and the goal to a first degree equation is to solve it. But when you win in football and you win in basketball, do you win the same way? No, the games are played differently. Well, do you solve a linear equation, a first degree polynomial equation, the way you do a second degree polynomial equation? No, you can't. And here's why. How do we solve a linear equation? We got the x's on one side, we got the numbers on the other. Well, if I try to solve, you don't have to write any of this down, I'm still just yakking right now. If I ask you to solve this problem, and by the way, why would I say solve? Because it's an equation. If I ask you to solve this, I would be wanting you to say, find the number for x that makes this work. Now, try to do it like we did linear equations, where you get your x's on one side, numbers on the other. All right, let's do that. All right, let's get the x's on one side. They are. Let's get the numbers on the other. They are. Now, you can't add these x's together. See, in linear equations, you get your x's on the same side because all of your x's is to the first power. The problem here is, when you get all of your x's on one side, you can't add these x's together. So let me say one more time. Do we solve a first degree polynomial equation called a linear equation? Do we solve it the same way we do a second degree polynomial equation or a third degree polynomial equation? No, we do not. So the question is, how do we solve this second degree polynomial equation? Now, before I get to that, let me just show you what the answer to this is. You don't have to write this down. The answer is 3. Now, let me show you that the answer is 3. Let x be 3. What's 3 squared? 9. Plus, what's 2 times 3? 6. What is 9 plus 6? 9 plus 6 is what? 15. So see, that answer works. But it turns out there's another answer to it. -5 is also an answer. Let me show you why. What's -5 squared? -5 times -5 is a positive 25. Plus, what's 2 times -5? -10. A positive 25 minus 10 is a positive 15. So that works too. Now, watch. What degree equation is this? Second degree. How many solutions did we find? 2 answers. Remember all the problems in 2.1? Linear equations, how many answers did you always find? 1. Now, there was an exception if it was no solution or all real numbers. But most linear equations, first degree equations, has one solution. Most second degree polynomial equations has two solutions. So you're saying, Mr. Ernie, you're telling me if this was an x to the third, would that mean, if it was an equation now, that's the key, if it's an equation, would that have three solutions? Yes, more than likely it would. Now, there's always the chance of no solution or all real numbers that we're not going to go into in these problems. So, how do we solve these polynomial equations of degree 2, degree 3, degree 4, etc.? Before we go into that, I want to throw out a name that you will hear a lot in college algebra, and it's this. Anytime you have a second degree equation, we give this a special name called quadratic equations. Quadratic equations. The word quadratic means degree 2. The word equation means equal sign. So, a first degree polynomial equation is called what? Linear equations. A second degree polynomial equation is called quadratic equations. Now, we call third degree polynomial equations cubic equations. You won't see that in here, maybe one, but most of what we'll be dealing with is quadratic equations. The main thing you need to let sink in is when you hear the word quadratic, that means degree 2, equation means equal sign. So how do we solve these second or even these third? We'll look at one, but mostly how do we solve these second degree polynomial equations? Well, before I show you that, let me say this one more time to drive this point home. Just to make this point one more time. These two problems are two completely different problems. This is a second degree polynomial. This is a second degree polynomial equation. I could call this a quadratic, but you can't call it a quadratic equation because there's no what? There's no equal sign. But this I can call a quadratic equation. So this is a quadratic, this is a quadratic equation. What's the difference? These we factor. These we solve. So in other words, if I ask you to factor this, trinomial, there's no GCF, it's the easy case, x squared, x and x, signs are different, largest is positive. I'm going to put the largest number right here. I need two numbers that multiply to give you 15, that subtract to give you a positive 2. That's 5 and 3. But the 5 has to be with the positive, the 3 has to be with the negative. This is that problem factored. The end. This is the answer to that problem. Now, the answer to this problem is going to be two numbers. 5 and 3, or 8 and 7, or 2/3 and -3/5. So the answer to this problem are the two numbers that makes this thing true. So this is a completely different problem than that, though they look very, very similar. And the key to that is that equal sign. So what I want to do on this video is I want to leave you off with a note on solving polynomial equations of degree 2 or higher. Solving polynomial equations of degree 2 or higher. All right, I'm going to talk slowly through the steps, and you pause the video where you need to pause it. Here are the steps. Step 1. Bring all terms to one side, leaving 0 on the other. Bring all terms to one side, leaving 0 on the other. Step 2. Put the polynomial in descending order. Put the polynomial in descending order. Step 3. Completely factor the polynomial. Step 4. Set each factor equal to 0. Set each factor equal to 0. And then step 5, solve for the variables. Solve for the variables. Okay, so those steps that I just gave you are the 5 steps in solving a polynomial equation. Now, will you always use all 5 of those steps in every one of the polynomial equations you ever solve? No, you won't. Some of the steps won't apply. You will see that in my next video. So what we're going to do in the next video is we will actually begin solving the polynomial equations. But before we get to the next video, I want to reiterate a couple of things on the steps. Look at step 1 again. Step 1, you're going to bring all the terms to one side, and you're going to leave 0 on the other. So everything's going to be over here. Step 2, you want to put this side right here in the right order. That means if it's a second degree polynomial, you want your x squared first, then your x, and then your number, if all those terms are present. Or if it's an x to the third, you want the x to the third first, then the x squared, then the x, and then the number, if all of the terms are present. So you got to put it in the right order over here. Step 3. If you'll notice, the first 2 words in step 3 says something that we have beat the life out of. And it is this: completely factor the left side. So when we get to step 3, we're going to use all of that stuff that we did in 5.5, 5.6, and 5.7 to get through those problems. Completely factor everything. Then step 4, we're going to set each one of those equal to 0 and solve. And I'll talk more about these 2 steps. When we get into the actual examples. So that concludes this video. We will begin the next video working some examples, section 5.8, video part 2 in the next section.